So for today, we're going to talk about theorems dealing with rectangles, rhombuses, and squares. Definition: a rectangle is a parallelogram with 4 right angles. While the definition contains the word parallelogram, it is sufficient to say a quadrilateral is a rectangle if and only if it has 4 right angles, since any quadrilateral with 4 right angles is a parallelogram. The properties or theorems will be stated in if and then form. Both the theorem and its converse, when you swap the if and then expressions, will be examined. Let's go back to the definition. A rectangle is a parallelogram with 4 right angles. Theorem: if a parallelogram is a rectangle, it has congruent diagonals. Another theorem: if a parallelogram has congruent diagonals, then it is a rectangle. So this is the proof of the statement 2. If a parallelogram is a rectangle, it has congruent diagonals. Given rectangle ABC, D, then prove line AC or diagonal AC is congruent to diagonal BD. Statements given for number 1. Number 2, angle DAB and angle CBA are right angles, since the definition of a rectangle has 4 right angles. Next, angle DAB is congruent to angle CBA, since all right angles are congruent. Because all right angles are equal to 90 degrees, and that means 90 degrees is equal to 90 degrees, and it is the reflexive property. For number 4, parallelogram ABCD, and its reason is a rectangle is a parallelogram. Number 5, the statement is diagonal AD is congruent to diagonal CB because opposite sides of a parallelogram are congruent. Line AD is congruent to line CB because opposite sides of a parallelogram are congruent. For number 6, line AB is congruent to line AB. The reason is the reflexive property. Number 7, triangle DAB is congruent to triangle CBA, and the reason is the SAS postulate. SAS means if two sides and the included angle of the triangle are congruent to the corresponding parts of the other, then the triangles are congruent. For number 8, diagonal AC is congruent to diagonal BD, and the reason is CPCTC. Corresponding parts of congruent triangles are congruent. Now, we're going to prove statement number 3. If a parallelogram has congruent diagonals, then it is a rectangle. Given rectangle ABC and diagonal AC is congruent to diagonal BD. Prove that ABCD is a rectangle. Parallelogram ABCD and diagonal AC is congruent to diagonal BD. The reason is given. Number 2, line AB is parallel to line DC and line AD is parallel to line BC. A parallelogram has two sets of opposite sides that are parallel. For number 3, line AD is congruent to line BC. Opposite sides of a parallelogram are congruent. For number 4, line AB is congruent to line AB, line DC is congruent to line DC. The reason is reflexive property. For number 5, triangle DAB is congruent to triangle CBA, triangle ADC is congruent to triangle BCD. SSS is the reason. If three sides of one triangle are congruent to the corresponding part of the other, the triangles are congruent. For number 6, angle DAB is congruent to angle CBA, angle ADC is congruent to angle BCD, and the reason is CPCTC. Corresponding parts of congruent triangles are congruent. For number 7, angle DAB is supplementary to angle CBA and angle ADC is supplementary to BCD. If two lines are cut by a transversal line, the interior angles on the same side of a transversal are supplementary. For number 8, the measurement of angle DAB plus measurement of the angle CBA is equal to 180. Same as for angle ADC and angle BCD. Supplementary angles are two angles that has the sum of 180 degrees. For number 9, measurement of angle DAB is equal to the measurement of angle CBA, and the measurement of angle ADC is congruent to the measurement of angle BCD. Reason: congruent angles are angles of equal measure. For number 10, measurement of angle DAB plus measurement of angle DAB is equal to 180, same for angle ADC, and that is just substitution. For number 11, 2 measurement of angle DAB and 2 measurement of angle ADC is equal to 180. And for number 12, measurement of angle DAB is equal to 90, measurement of angle ADC is equal to 90. And for number 13, angle DAB and angle CBA are right angles, and angle ADC and angle BCD are right angles. The reason is a right angle has a measure of 90 degrees. For number 14, rectangle ABC, and the reason is a rectangle is a parallelogram with 4 right angles. Moving on, we're going to talk about theorems of a rhombus. Definition: a rhombus is a parallelogram with 4 congruent sides. Theorem: if a parallelogram is a rhombus, each diagonal bisects a pair of opposite angles. Now, we're going to prove this statement. Prove: if a parallelogram is a rhombus, it has diagonals bisecting the angles. Given rhombus ABCD. Proof: line AC bisects angle DCB and angle DAB, and line DB bisects angle ADC and angle ABC. Statements: number 1, the given. Number 2, parallelogram a rhombus ABCD. A rhombus is a parallelogram with 4 congruent sides. Number 3, line AB is congruent to line DC and congruent to line CB and congruent to line AB. A rhombus is a parallelogram with 4 congruent sides. Number 4, isosceles triangle ADC and isosceles triangle DCB, triangle CBA, and triangle BAD are, and the reasons is the isosceles triangles has 2 congruent sides. Number 5, angle number 8 is congruent to angle number 3, and angle number 7 is congruent to angle number 4, angle number 1 is congruent to angle number 6, and angle number 2 is congruent to angle number 5. The reason is base angles of an isosceles triangle are congruent to each other. For number 6, triangle ABC is congruent to triangle CDA, and triangle ADB is congruent to triangle CBD. Diagonal of a parallelogram forms 2 congruent triangles. For number 7, angle number 8 is congruent to angle number 4, angle number 7 is congruent to angle number 3, angle number 1 is congruent to angle number 5, and angle number 2 is congruent to angle number 6. The reason is CPCTC. Corresponding parts of congruent triangles are congruent. Number 8, angle number 8 is congruent to angle number 7, angle number 4 is congruent to angle number 3, angle number 1 is congruent to angle number 2, and angle number 5 is congruent to angle number 6. The reason is transitive property. For number 9, diagonal AC bisects angles DCB and angle DAB. Diagonal DB bisects angle ADC and angle ABC. The reason is an angle bisector is arrayed in the interior of the angles for forming 2 congruent angles. That's for the first statement. Next statement, we're going to prove if a parallelogram is a rhombus, the diagonals are perpendicular. This is the proof. Prove if a parallelogram is a rhombus, its diagonals are perpendicular. Given rhombus ABCD, prove diagonal AC is perpendicular to diagonal DB. Statement number 1 given. Number 2, rhombus ABCD, and its reason is a rhombus is a parallelogram with 4 congruent sides. Number 3, line AD is congruent to line DC and congruent to line CB and congruent to line AB. A rhombus is a parallelogram with 4 congruent sides. Number 4, line AE is congruent to line EC and line BE is congruent to line DE. Diagonals of a parallelogram bisect each other. Number 5, triangle AED is congruent to triangle CED is congruent to triangle CEB and congruent to triangle AEB. Reason, SSS congruence. If 3 sides of a triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent to each other. For number 6, angle AED is congruent to angle DEC is congruent to angle CED is congruent to angle BEA. The reason, CPCTC or corresponding parts of congruent triangles are congruent. For number 7, measurement of angle AED is congruent to measurement of angle DEC is congruent to measurement of angle CEB and is congruent to measurement of angle BEA. Congruent angles are angles of equal measure. Number 8, measurement of angle AED plus measurement of angle DEC and measurement of angle CEB plus measurement of angle BEA is equal to 360 degrees. The sum of the angles surrounding a point sharing a vertex is 360 degrees. For number 9, measurement of angle AED plus measurement of angle AED plus measurement of angle AED plus measurement of angle AED is equal to 360 degrees. The reason for this is substitution. For number 10, for measurement of angle AED is equal to 360 degrees. Reason is combine like terms. For number 11, measurement of angle AED is equal to 90 degrees. Reason is division. For number 12, measurement of angle AED is a right angle, and the reason for this is a right angle is an angle with a measurement of 90 degrees. For number 13, diagonal AC is perpendicular to diagonal DB, and the reason, perpendicular lines meet to form right angles. That's it for rhombus. Moving on, definition. A square is a parallelogram with 4 congruent sides and 4 right angles. This definition can also be stated as a square is a quadrilateral that is also a rectangle and a rhombus. A square is a rhombus with 4 right angles. A square is a rhombus with 2 adjacent sides that are perpendicular. And a square is a rectangle with 4 congruent sides. Since we have already proven properties pertaining to the rectangle and the rhombus, no further proofs will be prepared for the square. That's all. Thank you for listening.